Airbus aircraft parts are transported using the Beluga cargo plane. However, when it comes to the world's largest passenger plane, the Airbus A380, it's impossible to transport its massive parts with just any airplane. No cargo plane exists that can carry the A380's giant sections inside. So, how are the parts of the A380, which are manufactured across Europe, transported to the assembly unit in Toulouse, France? Airbus, a European aircraft manufacturing company, produces 1,000 planes each year, delivering them to airlines around the world. This means Airbus is producing 3 new planes every single day. Just imagine, 3 brand new aircraft every day, a truly incredible challenge. But how are these planes made? That's a story for another time. However, how do the parts of these planes, which are made in various corners of Europe, reach the main assembly unit in Toulouse? Airbus's logistics system is the most complex transport network in the world, involving sea, river, land, and air transportation. Parts are made in different countries across Europe and then gathered in one place to create a magnificent aircraft. This is not a small task, but the result of decades of engineering and meticulous logistics planning. Back in the 1960s, the leading European countries, France, Germany, Spain, and the UK, dreamed of competing with the American aircraft manufacturer Boeing. Their goal was to create an alliance capable of producing large commercial airplanes. But there was a major issue with this partnership. Airbus's 11 production sites were scattered across different countries, each with its own expertise. For example, tail sections are made in Hamburg, Germany. Central compartments and nose sections are produced in Saint-Nazaire, France. Wings are created in Broughton, UK, and tail factories are located in Cadiz, Spain. Once the various parts are manufactured at these factories, a new challenge begins: how to send these football field-sized parts to Airbus's assembly unit in Toulouse, France. In the beginning, when demand for Airbus planes was low, trucks and ships were used to transport parts. This was a slow process, and the delivery of parts could take months. But as demand grew, waiting months for parts became a roadblock to the company's growth, especially since they now needed to build 3 planes per day. To solve this problem, Airbus found an ingenious solution. Inspired by the beluga whale, known for its hauntingly melodic call in the Arctic Ocean, Airbus created the Beluga plane in 1994. This plane was designed specifically to transport large and heavy aircraft parts, just like the whale's song inspired the name. The Beluga is not your ordinary cargo plane. It has unique features that set it apart from traditional aircraft. Measuring 56 meters, 184 feet, in length, with a height of 17 meters, 56 feet, it's as tall as a 7-story building. What makes the Beluga even more remarkable is its nose section, which can be raised like the bonnet of a car. This clever design allows Airbus to easily load and unload massive parts of aircraft. For example, the A350 wing pair, which spans 32 meters, fits seamlessly into the Beluga's fuselage. The value of just one wing pair is a staggering 40 million euros. Even the slightest damage during loading or unloading could result in huge financial losses, so every step is carefully planned and executed with great caution. Following the success of the Beluga, Airbus introduced the Beluga XL in 2014. This newer version has an even greater capacity, capable of carrying larger components and parts. However, despite these advancements, the A380, which Airbus launched in 2004, posed a significant challenge. The A380 is the world's largest passenger plane, with a fuselage height of 8.4 meters and wings that extend to 16 meters. The problem was that the Beluga XL, which has a cargo compartment height of only 7.5 meters, could not accommodate the A380's massive fuselage or wings. The fuselage, being cylindrical, is easier to transport in sections, but the wings must be built in a single piece to avoid structural weaknesses, as they contain essential components like fuel tanks and hydraulic lines. To solve this issue, Airbus considered developing an even larger version of the Beluga, called the Beluga XXL. However, redesigning the Beluga and increasing its engine capacity would have been extremely costly, running into billions of euros. Additionally, the A380's demand was limited, since only a few airlines could operate such a large aircraft, which meant that creating the double XL would not be a financially viable option. So, Airbus decided to drop the idea. Instead, Airbus shifted focus to finding a new method of transporting these massive parts. This is when the story of super convoys begins. Airbus started designing roll-on/roll-off ships, custom-built to transport large and heavy aircraft components across land, sea, and river, providing an efficient alternative for moving the A380's parts. Airbus uses roll-on/roll-off ships to transport large aircraft parts. One such ship, the City of Hamburg, is 126 meters long and 20 meters wide, with a cargo capacity 5 times larger than the Beluga XL. Parts are loaded at Hamburg port using rolling platforms, eliminating the need for cranes. Upon reaching Saint-Nazaire, the parts are transferred to barges that navigate the Garonne River to Bordeaux. The Pont de Pierre's bridge, built in 1810, has narrow arches, and the barges can only pass through when the tide is low. To tackle this, Airbus modified the barges by installing adjustable platforms. This feature allows the barges to lower their height during low tide and pass safely under the bridge. This small adjustment is a crucial part of the logistics, ensuring the smooth and timely transportation of parts despite the challenging river conditions. Given the size of the parts, traffic on the roads must be minimized, so these convoys travel only at night. During these hours, highways and city roads are temporarily shut down, and a 40-person team, including police, engineers, and escort cars, accompanies the convoy to ensure the safe passage of the parts. One of the most difficult tasks is navigating small towns, where the trucks have to carefully maneuver around roundabouts and narrow streets. Finally, when the parts reach Toulouse's assembly unit, the real magic begins. Airbus has high-tech systems in place that allow for the quick assembly of these massive aircraft parts. The A380, the largest passenger plane in the world, requires 19,000 rivets to connect the fuselage sections and 4,000 rivets to secure the wings. After that, the engines are added, the electronics are installed, then the plane is painted and prepared for delivery. From the manufacturing of the various parts to their transportation and assembly, the entire process of completing an A380 takes about 9 months. To date, only 251 units of the A380 have been built, largely because not all airlines can operate such a massive aircraft due to its size and operational costs. And that's a wrap on today's video. The Emirates A380 truly stands as a marvel of engineering, capable of carrying 850 passengers and weighing in at a staggering 575,000 kilograms, equivalent to 300 SUVs. With a price tag of $445 million, it's no wonder this aircraft is a game changer. The next time you fly, just remember the incredible teamwork and innovation behind every Airbus. If you enjoyed this video, don't forget to like, share, and drop your thoughts in the comments. Your support means the world to us. See you in the next exciting video.